Hi guys, so today we're looking at 2017 paper 1, question 1. So in this question we're asked to write the function 2x squared minus 7x minus 10 in the form of a times x plus h squared plus k. This is called writing your equation in general form. We like our equation to be in this form because we can find out a lot of information from it. The value of a tells you the stretch, i.e. if it's 2 times x plus h squared plus k, or 3 times x plus h squared plus k, it tells you how much your graph has been stretched. So if this is x squared, 2x would look like this, and 3x would be even more stretched. So the value that's in front there, which is the same as the coefficient in front of your x squared, that's it here, this tells you the stretch. And when our equation is written in general form, we can also find the minimum point. So when our equation is written in the form of a times x plus h squared plus k, the minimum function of your graph, or the minimum point, is minus hk. Okay, so let's say you had a function which was x squared. The h and the k value tell you your shift. So the value that you're adding onto the x tells you the shift on the x-axis, and the value that you're adding onto the y tells you the shift on the y-axis. X plus h squared plus k. We have shifted your function over and up by a certain amount. So this tells you your minimum point. Okay, now we have to figure out how we can write it in this form. When writing your equation in general form, there's a certain simple steps that you have to follow. The first thing we must do is take your equation and divide by the coefficient that's in front of the x squared. So we can't put this into general form until we've divided everything by the coefficient that's in front of the x squared. And we're left with x squared minus 7 over 2x minus 5. Now, take your c coefficient, i.e. the value that's on its own, and bring it to the other side of the equation. This gives us x squared minus 7 over 2x is equal to 5. We now remove bx from your equation entirely, and we replace it with the square of your coefficient attached to the x. So we remove bx completely, i.e. remove minus 7 over 2x completely, and replace it with the square of that x coefficient, minus 7 over 2 squared. To balance your equation, you have to replace it on both sides. This gives us x squared plus minus 7 over 2 squared, leaving it in squared form, which is equal to x plus minus 7 over 2 squared. From here, we group together our values that are squared on the left-hand side of our equation. So we're going to group together x minus 7 over 2 and bring the square to the outside. And then looking at our right-hand side, so taking our right-hand side, we are going to simplify this by grouping together those like terms. So into our calculator, 5 plus, in brackets, minus 7 over 2, close your bracket, squared, which gives you 69 over 4. From here, we want everything on one side of the equation, so we bring the right-hand side to the other side of our equation. This gives us x minus 7 over 2 squared minus 69 over 4. And that's all equal to 0. Finally, we divided everything by 2 at the start, so now we must multiply everything by 2 again. So I multiplied this bracket by 2, and I multiplied the number that's on its own by 2. Tidying this up gives us 2 times x minus 7 over 2 squared minus 69 over 2. Okay, so now we have our function written in general form. To do this, let's just go through it again. Divide everything by the coefficient in front of your x squared. Remove your bx value and replace it with the square of the bx coefficient. Group together your squareds. Bring everything to one side of the equation and multiply in the coefficient that you divided at the start. Now that we have our equation in this form, let's look at part B. Write down the minimum point of f. Well, as we said at the start of this video, the minimum point of f is minus hk. So in our case, if our function is 2 times x minus 7 over 2 minus 69 over 2, our minimum point is 7 over 2, remember you're flipping that sign on the x, comma, minus 69 over 2. Okay, and from here we're asked to explain why f must have 2 real roots. Okay, so we're looking for why it has 2 real roots. If you see this in the exam, if you're asked to show that your equation has no real roots, 1 real root or 2 real roots, we look for the discriminant. The discriminant is equal to b squared minus 4ac. If your discriminant is less than 0, your function has no real roots. If your equation for your discriminant is greater than 0, then we have 2 real roots. And if your discriminant is equal to 0, then you have 2 real roots that are the same value. So you have 1 real root. Okay, so let's figure out how this function has 2 real roots. Our function is 2x squared minus 7x minus 10. Let's find our value for our discriminant, where a is the coefficient in front of the x squared, b is the coefficient in front of the x, and c is the coefficient that's on its own. Our discriminant here, b squared minus 4ac, is equal to minus 7 squared minus 4 times 2 times minus 10. Let's multiply this out. This gives me 49 plus 80. And 49 plus 80 gives me 129. This value is greater than 0, so our discriminant is greater than 0, and therefore I have 2 real roots. Let's look at part 2. write the roots of f of x is equal to 0 in the form of p plus or minus the square root of q. So if we're asked to find the roots of our equation, correct to 2 decimal places, or insert form like we're asked here, it means that your roots are not whole numbers. And so to find the roots, we have to use our quadratic formula. You might know it as your minus b formula. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Our equation is 2x squared minus 7x minus 10, which gives us a is equal to 2, b is equal to minus 7, and c is equal to minus 10. Substituting these values into our quadratic formula gives us minus 7 plus or minus the square root of minus 7 squared minus 4 times 2 minus 10 all over 2 times 2. Okay, let's multiply this out and find our roots. Minus times minus 7 gives me plus 7. Plus or minus the square root of 129, because that's our discriminant value, it's the same thing, all divided by 2 times 2, which gives us 4. This gives me values of x as x is equal to 7 plus the square root of 129 over 4, and x is equal to 7 minus the square root of 129 over 4. We're asked to give our answer in the form of p plus or minus q, which is what we have given. Okay, and that's the roots of our equation. All right, thanks very much, and I hope this helped.